Hey guys, BuildZoid here, and today we're going to be taking a look at the Gigabyte Z690 Aorus master motherboard. So this board is obviously provided to me by Gigabyte, so thank you to Gigabyte for providing the board. I also have a Z690 Aorus Extreme. The video on that will be coming later, because I don't really, like, $900 motherboards in my opinion aren't really a priority. So anyway, this is not $900. This goes for around $470 at the time of shooting this video, according to Newegg. And it's still kind of an awkward motherboard to justify, just because at least a lot of the stuff I care about is already on the Z690 Aorus Pro, which is like $330. So, you know, there's like a board that does most of what this does for much less. But this does have some interesting extra features, and also some sort of, well, yeah, it does. This does have some extra, like, interesting extra features. So let's get into it. Starting off with the rear I/O, where you get a clear CMOS button. So you know you don't. Well, the thing is, the board does have a safe boot function, or at least should have a safe boot function, sometime soon in the future. So I don't know how much you actually will use the clear CMOS button, but if you need it, yeah, it's there. There's a Q-Flash Plus button, allows you to update the BIOS of the motherboard without like having a CPU installed even. You get Wi-Fi 6 from Intel, a bunch of USB Type-A ports, 10 gig Aquantia LAN, and this is one of the sort of like weird features that you get with this board. Like if you're looking for 10 gig LAN, this is one of the cheapest motherboards with 10 gig LAN. So that's cool, I guess, but if you don't need 10 gig LAN, you can save a whole bunch of money by just getting something cheaper. So yeah, other than that, there's also a display output for the iGPU, and then you get two USB Type-C ports, as well as the full set of like audio ports that you get on a motherboard, which admittedly, if you go down to like the Aorus Pro, you don't get these three ports over here. Well, actually, you get the mic in and you get a line out, but you don't get, well, you don't get all of the ports. I don't pay enough attention to onboard audio. I don't even know what any of these terms mean. Anyway, moving on from the rear I/O, on the board itself, you will find 5 M.2 slots, and there's some weirdness going on with the bandwidth sharing, because of course there's not enough PCIe lanes to go around for all this. Right, obviously this one's just connected directly to the CPU, and then I think these two might be directly to the chipset, and there's nothing weird going on with them, but then there's 2 M.2 slots where one shares some lanes with one of the PCIe, like the X4 PCIe slots, and one of them shares with a SATA port or a couple SATA ports, something like that. The manual has more details if you care about that. Point is, you do get an awful lot of like options for M.2 drives on this board. You don't have to use them if you don't want to. Anyway, and this is sort of where we get into the weirdness with this board, because you know, in the PC, not the M.2 drives, this is a, like, at this price point, the number of M.2 drive slots makes perfect sense. The weirdness is the PCIe, like the PCIe configuration, because you only get the X16 Gen 5 up here, and then these two PCIe slots are off of the chipset, which... yeah, like, that's a bit weird, because at this price point, most other motherboards will opt to have PCIe Gen 5 PCIe switches, and so you'll get a, like, you'll get the option of X16, X8, and then you'll have, like, another X8 slot somewhere on the motherboard. That's also Gen 5 that's connected to the CPU. So if you need a motherboard with 2 PCIe slots connected directly to the CPU, well, this doesn't do that, which is a bit weird, because past master motherboards would have usually been actually pretty good about offering that functionality, though admittedly Gigabyte now has like the Aero series of motherboards, you know, the ones targeted, like, which used to be the Vision boards, the white ones, right? The ones targeted at creators, and the Aero D is basically a master, but with actual PCIe switches. So I guess that's what's going on there, is just like, if you want more PCIe slot flexibility, the Aero D exists. If you want 10 gig LAN and a bunch of M.2 drives, the master exists. That's kind of the idea here, at least as far as I can tell. You know, neither 10 gig LAN nor M.2s are something I particularly care about, so I have a really hard time understanding, like, what the hell you would do with this board, but I guess put a bunch of M.2 drives in it and then use it as a NAS with the 10 gig networking. Anyway, let's talk about other features I do care about. So we do have the reset switch, well, the rebindable reset switch. I think Gigabyte calls it like multi-key or something. Anyway, I did end up looking up if they have a better terminology for that, but like on the board, it's labeled reset switch. So anyway, rebindable reset switch, it can function as a safe boot button. At the time of shooting this video, it was not functional yet. They still need to implement that functionality in the BIOS, but they had this feature on Z590. On Z590, it was amazing. If they get it working on Z690, it'll be amazing, because safe boot is just one of the greatest, like, you know, like quality of life features for memory overclocking that there is, because you don't have to constantly save profiles so that you don't lose your progress when, you know, dialing in memory timings. Also, if you do anything stupid, like, it just makes recovering from any screwed up settings so much more convenient. So this is like literally my favorite feature to be added to a board in recent history. By default, it just acts as a regular reset button. There's also a, actually wait, that's EC temp, so that's temperature header. I think, where did they put it? Because there's supposed to be a jumper. Oh, there's the reset switch jumper. That is really awkward. So on the Aorus Pro, the jumper for the onboard button, so that you can connect the button, like, so you could wire up like your case's reset to this functionality. So on the Aorus Pro, they're right next to each other, but here it seems to be right over there. But you do still get a header for that. So yeah, you can still wire up the reset switch to your case's reset reset button. You don't have to like reach inside the, you know, take the side panel off and reach inside to use safe boot once that's implemented. Single BIOS over there, clear CMOS jumper over here. Totally redundant troubleshooting LEDs, because you do have a postcode right over there. And postcodes are amazing. If you do a lot of overclocking, you should get a motherboard with a postcode. It'll make your life so much easier. Actually, postcodes is just in general, or if you work on like dead GPUs, also very helpful for that. Yeah, so I love postcodes. Postcodes are dead. I mean, great. Don't know why I said dead. Anyway, yeah, postcodes are amazing. But you can also, like, this is another feature that you get on the Aorus Pro for like $140 less. So, yeah, anyway, next to that, you find a power button. Hiding above the DIMM slots, we get some voltage read points, which is unique to the Master. Unfortunately, they're not labeled. So that's fun. Good luck figuring out which voltage read point does what. Yeah, they aren't labeled. Maybe the manual tells you what order they're in, but they're not labeled directly on the motherboard. And actually, wait, they are. It's right here. Talk about, you know, yeah, that is definitely voltage read points, because there's not really anything else that could be. Like the DIMM slot indication is over here, right? So, yeah, anyway. Okay, so I'm blind. I did not realize they put that there. Like, because I looked at the board, and like, normally I'd expect the labels to be, like, right next to it, and it makes sense. Like, there's obviously not enough space between the fan headers up there, but, yeah, so you do get labeled voltage read points. I'm just blind. Anyway, so that covers sort of the feature set of the board. And yeah, it's kind of weird. Like, the highlights with this board is, like, okay, you get 10 gig LAN. For Gigabyte, it's one of the boards that has like 5 M.2 drives. Most of their other boards have, like, their cheaper boards have generally just 4 of them. So yeah, but personally, like, I'd rather have the cheaper motherboard. But there are some other upgrades that Gigabyte has made that aren't as obvious. They're not just straight up feature set things. Like the fact that, I'm not sure how to show this. So I guess we'll just go to the back of the board. And GIMP is being very cooperative today. This uses an 8-layer PCB, which makes sense. It's a $470 motherboard. It better be using an 8-layer PCB, because at this price point, having a 6-layer would be insulting. Yeah, so we've got an 8-layer PCB. And the funny thing is, like, most of the time when you have an 8-layer PCB on the motherboard, it's used because there's tons of PCIe lanes running around, which I guess maybe with all the M.2 drives that Gigabyte has going on here, that might be part of it. It's just, you know, the extra layer count is partially for that. But also, what is cool about having higher layer counts is it improves the efficiency of the actual power planes for, like, V-core and, well, V-core mainly. Like, that's the main power rail. That's the one that, you know, causes the most thermal issues. So having more PCB layers does help reduce VRM thermals and slightly improve VRM efficiency. So yeah, this does have an 8-layer PCB, which, say, the Aorus Pro or the other Gigabyte motherboards that are cheaper than this are all 6-layer PCBs. So that includes, like, the Aorus Ultra, which is basically this very slightly upgraded Aorus Pro. So yeah, so this is sort of the cheapest 8-layer PCB that Gigabyte, you know, sells. And I guess with that, let's talk about the actual power delivery itself, which I guess we could have stayed on the back of the board for that, because for the power connectors, Gigabyte is using the high current variant of the 8-pin power connectors. You only need one of these plugged in if you're on, well, if you're not doing extreme overclocking with like liquid nitrogen or something, you don't need to plug in both of these 8 pins. One of these can easily handle 400 watts or more. And yeah, you don't need to plug in both of them because you're not going to be pushing 400 watts into your 12900K under the vast majority of circumstances. It is technically possible to get the motherboard to pull 400 watts for a 12900K. You're going to need a hell of a lot of cooling because that would mean you're pushing like over 300 watts into the CPU itself. And from about 260, well, yeah, from like 300 watts already, like at 300 watts already, the 12900K is a very hard CPU to cool. So you really don't need to plug in both of these 8 pins unless you've got like a insane cooling system for your CPU. So if you have a power supply with just one 8 pin, don't worry about it, right? Though if you're buying a motherboard this expensive, your power supply really should have 2 8 pins, just by the way. Anyway, let's talk about the VRM itself. So this is not the biggest VRM on Z690. Like, the thing is, with Z690, Renesas, like, the motherboard manufacturers have gone insane. Partially because Renesas is, like, enabling them to. So, I should put up the phase, like, the rail splits first. So, obviously, down here we have VCC in. Then this over here is iGPU, and all the rest of this is vCore. And so, yeah, Renesas is enabling just absolutely ridiculous VRM configurations on Z690 because they have the RAA 229131 voltage controller, and that thing goes up to 20 phases. And so on boards like the Z690 Master that we're looking at here, this thing is running in 19+1 phase mode. Yeah, that's that 19-phase vCore, 1-phase iGPU. The VCC and rail is handled by a different controller. That's a Monolithic Power Systems MP2940, which is just a 2-phase controller. Yeah, so 2-phase controller for VCC in. But yeah, the vCore is an absolute monstrosity in terms of just sheer phase count. And then in terms of power stages, it's more of the same. As Renesas has now released the RAA 220105. And the 0105 is actually the nominal current spec on these. These are 105 amp nominally. Okay, and I say nominally because you are not pushing 105 amps through a chip this big and not having major thermal issues, okay? Like, technically speaking, under very specific operating conditions, one of these power stages can do 105 amps. This VRM right here, as configured, does not do 1900 amps, okay? Like, I've seen some... Like I've seen this popping up again on the internet where people just multiply the phase count by the current nominal current spec of the power stages and they go like, oh, this is like a 2000 amp VRM. No, it isn't. Like, it will overheat if you try to do that. But anyway, they are nominally 105 amp smart power stages. Now, smart power stages are smart because they integrate a bunch of extra functionality like temperature monitoring, current monitoring, over temperature protection, over current protection, and other safety features. So they're called smart because unlike, say, dumb power stage, like a dumb power stage wouldn't have all that extra functionality built in. So these are called smart power stages for that reason. And the 105 amp nominal current rating is kind of misleading. Because these, for the 1.2 volt output voltage, these have a peak efficiency of a little over 94%, which, funnily enough, is basically the same peak efficiency as the 90 amp ISL 99390s. So I wouldn't really be that, and by the way, Renesas owns Intersil for a while now, so I wouldn't be too surprised if this was like a revised version of the ISL 99390, where it's like, it doesn't actually have any higher efficiency, but you can, within certain operating conditions, this can survive 105 amps, whereas the 99390s can't. ultimately what this means is that this VRM will ultimately run cooler than the VRM on the Z690 Aorus Pro, but it's not going to be because of the power stage plus inductor efficiency. And the inductors on this motherboard are the same inductors that Gigabyte uses on the Z690 Aorus Pro. And also it's worth noting the Z690 Aorus Pro is a 16-phase V-Core VRM, also using that RAA 229131 controller. But the Aorus Pro uses the 90 amp intercell, nominally 90 amp intercell ISL 99390 chips instead of these nominally 105 amp chips. Now the thing is, at 1.2 volts output voltage and 500 kilohertz switching frequency, the heat output of the inductors and the power stages, so SPS plus choke, right, like they're inductors, but chokes also works, and this is shorter. I'm not going to write out inductor. You can see that I'm not very fast at writing. Anyway, so the heat output for the power stages and the inductors at 200 amps output should be about 15 watts of heat. And if you watched my video about the Z690 Aorus Pro, you would know that board also produces about 15 watts of heat at 200 amps output. Now, this VRM will still end up running cooler because you have an 8-layer PCB, so the PCB, there's less heat produced by the power plane of the board. The board acts as a better heatsink for the VRM as well. Then also there's just 19 power stages instead of 16, so that 15 watts of heat is spread across 19 power stages and inductors instead of just 16 of them. The board also has a far more elaborate heatsink design with a hell of a lot more surface area. This monstrosity right here, though I'd say the heatsink on a motherboard like this is borderline irrelevant, as you could run it without the heatsink either way. Like, that's the, and I've done videos about this, like the Z590 Aorus Extreme. I think I did a video where I ran Prime 95 until the board leveled off at a little under 100 degrees Celsius with no heatsinks whatsoever. And yeah, like, once your VRM gets into this sort of, and that was a 16 phase, that wasn't even 19. Actually, that wasn't even a proper 16 phase, if I remember correctly. Anyway, so, yeah, like, this VRM is just so insanely huge. Also, you might be looking at this fin stack right here and wondering, how is this supposed to work in a standard, like, you know, case orientation? Because the hot air wants to rise, and the fins aren't really oriented for that. Well, Gigabyte did think of that. They have holes punched into the sides of the fins throughout the entire array. So actually, like, hot air can travel through the fin stack sideways. It's just not as efficient as if you were trying to, like, honestly, this fin stack orientation just doesn't really make a ton of sense. Luckily, it doesn't have to make a ton of sense, because the VRM is so ridiculously overkill. Like, again, once you get into the territory of, like, the VRM will literally not overheat even if you didn't have a heatsink, the heatsink is there more for aesthetic purposes than it is for actually achieving anything. Like, yes, it'll make the VRM run slightly cooler because more surface area, even if not necessarily being used as efficiently as it could be, is more surface area, but the VRM would be fine with, like, not this. Like, they could have removed the fin stack and just left the base plate that the fin stack is attached to, and that would have probably done a perfectly good job as well. And yeah, but, you know, the fins, like, the fins do look nice. They are, you know, aesthetically pleasing, I guess, in a way. Not very useful, though. More like very extremely unnecessary, but yeah. So at 200 amps output, it'll produce about 15 watts of heat, which is, again, in line with what the Aorus Pro would do, but because there's more, just, you know, like, you have more power stages, that the heat, like, the thermal density is lower, the PCB has more layers, and it has a sort of bigger heatsink. Like, the funny thing is that heatsink isn't even that heavy. Like, the board is really heavy, the heatsink isn't, which is super weird. Like, normally, like, with a lot of motherboards, the thing that gives them heft is the heatsinks. And this board, you take off the heatsinks, and it's still heavy. So, which I think is just down to the fact that there's so many inductors, and I guess also all the, like, aluminum plates for the M.2 covers, which I didn't end up taking off, because, you know, there's a lot of them, but yeah, this board has mass to it, and a lot of it is just in the VRM components themselves, so yeah, thermally, it'll do great, because the Aorus Pro already does a perfectly good job, and this is just excessive to the extreme. Like, in the past, this type of VRM would be what you'd get on on an extreme class board from Gigabyte, and now it's on a master. And they didn't like, that's $470. I think that's still technically cheaper than even the Z390 Extreme. I think that board was $550. So, and it's not like they've jacked up the price too much. Anyway, 300 amps output. And as we get into the higher current outputs, this VRM does start pulling away from the VRM on the Aorus Pro. It's just that you're not pushing 300 amps into a 12900K. Or, well, like, good luck with that. Like, good luck cooling that. the CPU, not the VRM. The VRM doesn't care, because the VRM at 300 amps output would still produce only about 22 watts of heat. So, yeah, like, the VRM here is just ridiculously excessive overkill. 400 amps output, you're going to be looking at about 31 watts of heat output from the power stages and inductors. 500 amps output current, it'll be producing about 42 watts. So at this point, the heatsink starts actually, like, in this area, the heatsink starts actually being somewhat useful. As you're not going to, like, basically, a good rule of thumb is if you're producing less than 2 watts per component in the VRM, less than 2 watts of heat per power stage, the VRM can run without a heatsink. Assuming that you also don't have like a 4-layer PCB. So, yeah. Anyway, 600 amps output, and this is really just for fun. Like, even on LN2, I don't think a 12900K is going to exceed the 500 amp mark. But at 600 amps output, this VRM would produce about 55 watts of heat. Really, this VRM is more along the lines of what you'd want to see on like a Threadripper motherboard rather than a mainstream Intel board. But, you know, at the same time, it's not that insanely expensive. Like, it's compared to some of the other Z690 motherboards, $470 is actually downright affordable. Like you've seen the prices, right? Like, for the high-end Z690s, things go absolutely insane. So yeah, and the like power delivery wise, this board right here is just massive overkill for a 12900K. Now, in terms of filtering, what's kind of interesting is this actually has less input filtering capacitors than the Aorus Pro. I don't think that'll actually make any noticeable difference to the performance. I really kind of suspect that the bulk capacitance on the input side of the VRM of the Z690 Aorus Pro is very excessive. Yeah, it is kind of interesting that, like, this board does only have 6 bulk capacitors for the input, whereas the Aorus Pro had 8 of them. I still don't, like, admittedly, this has less space. Like, part of that is because there's a bunch of heatsink going through this area, right? Like, the heatsink basically takes up all of that space, so you can't exactly put a row of capacitors over there. But they could have probably squeezed a few more capacitors in this area, or just put, like, two more like that or something, but either way, wouldn't really make a difference, doesn't really matter. It's just kind of weird that you have a higher end board with less stuff on the input side. Because historically it would always be like you just get more and more and more and more. But performance, like, still, like, I don't think it's a performance thing. It's just weird. That's, like, I don't think it's a cost cutting thing. It really looks to be like they just ran out of space and it was like, okay, we're just don't. It's not necessary. Now, the output filter, however, did get some upgrades. So on the back of the board, we do have the sort of classic modern Gigabyte high-end motherboard capacitor, like filtering, capacitor configuration of a mix of multi-layer ceramics and tantalum polymer capacitors in the socket. So that's on the back. Then on the front, we just have a full mix of just all multi-layer ceramics, because on the front of the board, this is where the multi-layer ceramics are most helpful, is on the front of the board. So you have that. But and this is the same, like the socket configuration is the same as what you get on the Aorus Pro. So multi-layer ceramics on the front, mix of tantalum and ceramic on the back. But the sort of difference here with this board is that you also get these tantalum polymers around here. There is only 3 of them, and I have a really hard time believing that they make too much of a difference. But it's also worth noting that the board does also have an 8-layer PCB, which can also slightly help with voltage regulation because you have less impedance between the VRM and the CPU socket. And so overall, this does have some like voltage regulation upgrades over what the Z690 Aorus Pro has, but I don't think they would be like, I'm pretty sure the Z690 Aorus Pro already has is well past the point of diminishing returns, and this is just pushing it further. So, while there's no harm at what Gigabyte is doing, I'd be very surprised if this made a noticeable difference in overclocking capabilities. At ambient, I don't think it'll make any difference, Maybe on liquid nitrogen there might be a slight advantage, but even that I really, really doubt it. But yeah, like, you know, at this price point, I guess it's kind of what you'd expect, right? Like just excessive amounts of overkill. And this board does deliver exactly that, so I guess you can't really complain too much about it. Like, at least you're getting stuff, you know, like you're getting extra stuff on the board for the money that you spent on it, so I guess that kind of justifies it. Interestingly enough, the Aero D actually ditches these extra tantalum capacitors. Oh man, now I really wish I had a probinator for Z690. Actually, no, I don't. Well, no, I do. I wish, because the thing is, I've decided for Z690 I don't really want to go through the hassle of, you know, hooking up the oscilloscope directly to the CPU. You can't, actually with Gigabyte, if it's just Gigabyte motherboards, it shouldn't, like the problem is if you have different capacitor configurations between the motherboards in the socket and you choose a specific capacitor to measure from, your measurements don't work because they're different, right? Like you don't know that you're measuring from a capacitor with the same impedance as on the other boards, so your measurements are garbage. But if you're only comparing like 8-layer Gigabyte boards against each other, you could actually just measure on the motherboard instead of, so yeah, once I get the Aero D, I might do that. Just hook up the oscilloscope to the back of the board and see if there's any difference between having those 3 tantalums and not having them. I really think there's no difference. That's 3 capacitors. If 3 capacitors make a difference, I'll be very surprised. But anyway, yeah, so that's the VCore VRM, and like I think I've made my thoughts on it clear, right? Like massive, excessive overkill. Though I do kind of like the fact that it does have an 8-layer PCB. Oh, and I guess I should have also mentioned that this board does use a higher, like a thicker gold plating on the pins in the socket than the Aorus Pro does. I'm not, like, that is significant if you're swapping CPUs a lot as the gold plating wears off, but if you only install your CPU once, that really shouldn't affect you in any way, shape, or form. Like, all the pins are gold-plated, it's just like these have a bit more gold plating on them than what you'd get on a Z690 Aorus Pro. So, anyway, yeah, so that's VCore. The iGPU does actually use a different power stage that uses an ISL 99390. And then for the VCCN, we've got the exact same VCCN configuration that we had on the Z690 Aorus Pro. So you've got your MP2940 two-phase voltage controller, and then 2 power stages from Monolithic Power Systems, which are MP87992s. These are 70 amp smart power stages. And I've finally got information on like the Intel documentation for the LGA 1700 platform. Says that VCCN max current output should be like 33 amps, which still sounds ridiculous to me, right? Like at 1.8 volts, 33 amps is, because there's a integrated voltage regulator inside the 12th gen CPUs, and that's what this VCCN rail powers, and that takes 1.8 volts. So the thing is, 1.8 volts, 33 amps is like, that's almost 60 watts of power. Right, or that's somewhere around 60 watts of power, which is an awful lot of power for what is like the L2 cache of the E-cores and some memory controller rails. So I like this right here from Gigabyte is very overkill. In fact, a lot of other manufacturers have a VCCN that's just half of, like literally half of this. Like they just ditch one of the 2 power stages because the VCCN rail really shouldn't be pushing that much power at any point. But either way, at 40 amps output, which is again above what the Intel spec is, this VRM over here should be producing only about 4 watts of heat, and that's spread across 2 power stages. So this too would be completely fine. Like actually, this is probably the rail that would be most like on the boards that have a single phase VCCN. This would be probably the rail that would be most affected if you tried to run the VRM without a heatsink. But here, even VCCN would not care. So, yeah, that's kind of neat. So, power delivery wise, massive overkill. I like already with the Z690 Aorus Pro, it's kind of like, you know, well into the like past this point, like with the Z690 Aorus Pro, going any further is like, okay, you're going into diminishing returns. This right here is like, I don't know what the point is going past this. I know for a fact that there are Z690 motherboards with even more excessive VRM designs on them. I really don't see the point in that. Though I do wonder how this VRM would perform if they replaced all the through-hole Nichicon capacitors with SMT tantalum polymers, or SP caps. Preferably aluminum polymers, because those do perform a bit better, but anyway. Oh, and I guess I should have mentioned that as in standard high-end Gigabyte fashion, all of the all of the through-hole capacitors are Nichicon 10,000 hour rated FP caps. So that's 10,000 hours at 105 degrees Celsius, and that's just kind of standard for high-end motherboards to use 10,000 hour rated capacitors like that. Also, yeah, and so those caps will last forever because the VRM shouldn't be getting that hot anyway. Now let's talk about the memory topology, which I don't know if it's any good. I do, however, know what it is. So as I mentioned earlier, the board is an 8-layer PCB. And this is a daisy chain topology, and yeah, I don't know if it's any good, and it's shielded, right? And I guess I should have put that there as well. And so the reason it's shielded is we can't see any of the data traces, right, on the top layer or on the bottom layer of the board. You can see some of the command address bus stuff, but you can't see any of the data lines going to the CPU. So this is a shielded daisy chain topology. Also, this is a DDR5 motherboard, so of course it uses the SMT DIMM slots because DDR5 runs at frequencies so high that the pins of the DIMM slots are actually a major problem for signal integrity at these kinds of speeds. Also, the same goes for the PCIe Gen 5 slot. That's also an SMT slot right there. And what else is there? Oh, I forgot to mention Gigabyte does have a backplate for this. Like, the board does have a backplate, which is a really cool... Like, I like backplates. Like, motherboard backplates are cool because they just make the motherboard a lot more rigid. They're also... Like, they also have thermal pads for sinking heat from the VRM. Again, the VRM barely needs a heatsink, so the... the usefulness... Like, there's no harm in doing this. At the same time, it doesn't really make, like, it shouldn't really be making too much of a difference to the thermals of the board. But yeah, they are using the backplate for some extra heat sinking. Also for the 10 gig LAN, there's extra heat sinking right there. And you can actually, like, the 10 gig LAN chip is like in this area, and that's probably part of why that VRM heatsink is so ridiculously massive, so that it can actually reach all the way to the 10 gig LAN chip. Which, like, if you look at other Gigabyte boards with 10 gig LAN chips, like, they'd have, like, a weird jutting out part of the VRM heatsink just to cover the 10 gig, and now it's just like, nah, it's just bigger heatsink. It covers everything now. No, that really makes, like, it doesn't, like, it's not that the 10 gig needs this much cooling, it's just from I guess from an assembly, like, some motherboards will opt to have, like, a separate small heatsink for just the 10 gig LAN. Gigabyte generally just integrates the 10 gig LAN cooling into the VRM cooling on the boards that have 10 gig. So, yeah, that's just like a Gigabyte design thing for their motherboards. And yeah. Also, I guess the backplate does help in that you won't knock off any components off of the back of the board if you're, handling it or something like that. So, yeah, anyway, that is the Z690 Aorus Master. There's, like, massive overkill. Like, in the past, like, the only difference between... Yeah, in the past, this would have been an extreme as far as I'm concerned. Right? Like, like, this would have just been an extreme. Like, compared to the Z590 Extreme, admittedly, this does have less flexibility in the PCIe lane assignment compared to the past Extreme boards, but in terms of build quality, like, layer count, because the Z590 Master, that was a 6-layer PCB. So now the Master is an 8-layer PCB, the VRM is mega overkill, like, so incredibly overkill. I cannot overstate how overkill this is. The heatsinks got bigger, you get the 10 gig LAN, though they started doing that with Z590 if I remember correctly. Hopefully they get Safe Boot working sometime soon, which, once they do that, like, the board will be amazing. Like, the biggest argument I see against buying this motherboard is that the Z690 Aorus Pro exists. And the Z690 Aorus Pro does exist, and it's, $140 less, and all you really lose is, okay, so you lose 2 layers of the PCB. The VRM is going to run somewhat hotter, but still at perfectly acceptable temperatures. You lose the 10 gig LAN, but if you don't need 10 gig LAN, that's not really much of a loss. And you lose one of the M.2 slots. And, like, that's it. Right? And, like, to be fair, The 10 gig LAN is expensive. This VRM is expensive. Like, there's a lot of reasons why this board costs what it does, but as well as the heatsink, right? Like, this is a lot more expensive to manufacture than what you get on the Aorus Pro, which is basically just two, I'm assuming, extruded and then machined slabs of aluminum. But yeah, the thing is, the Aorus Pro already performs really well, and this is just kind of like I've not yet noticed a difference between the boards. Maybe this will have some advantage in memory overclocking due to the extra layer count, but yeah, from my initial testing so far, I've just not noticed a difference between the two boards. Like, I've been using them kind of interchangeably. Really, the only reason I've been switching between them is waiting for whichever one gets the BIOS update that fixes safe boot first. That's probably the one I'll be using most. Because yeah, this board is just kind of, I don't know, like there's nothing wrong with it. It's just also very, very excessive in so many ways and very expensive. So yeah, cool board. Just like, I feel like Gigabyte kind of shot themselves in the foot with the Aorus Pro, because it's just like, how, like, I don't know. Maybe, like, I guess it's because I don't care about M.2 drives or 10 gig LAN, but yeah, I have a really hard time, like, trying to explain why you should buy this instead of an Aorus Pro. But hey, you know, that's not my job. That's basically Gigabyte's job, right? To justify why you should buy this instead of one of their cheaper boards. But anyway, that's it for the video. So thank you for watching. Thank you to Gigabyte for providing the board. Man, I feel kind of bad for ripping on it towards the end like that, but it's true. It's just like, it's an Aorus Pro, but like $140 more for 2 extra like, if you're not using the M.2s and the 10 gig LAN, it's 2 extra layers for $140 extra. Anyway, yeah, cool high-end board, I guess. And that's it for the video. So thanks for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. If you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There's a link to that down in the description below. There's also the HOC Teespring store where you can, you know, get YouTuber merch, shirts, stickers, posters, hoodies. There's hoodies now, and like zipper hoodies. We used to have regular hoodies. Now we have zipper hoodies, which are way better because pullover hoodies are dumb in my opinion. Anyway, yeah, so Teespring store, both Patreon and Teespring help out immensely with running the channel, so if you'd check them out, that would be much appreciated. And that's it for the video, so thank you for watching, and goodbye.